similar. No proof, so you're going to just explain why. At the top, like I said, in order for any polygons to be similar, all the sides have to be in proportion and all the corresponding angles have to be congruent. So when you were comparing two parallelograms, you had to make sure all four sides are proportional and all four angles are congruent. If you're comparing two hexagons, all six angles and all six sides had to be proportion and congruent. For your triangle on your quiz, you had to check that all three pairs of angles were congruent and all three sides were in proportion. Today, you're going to learn 3 shortcuts, so you don't have to do all that. The first way to prove that two triangles are similar is using the angle-angle similarity. You can just write down the abbreviation. You don't have to write all the words out. Angle-angle similarity. If two angles in one triangle are congruent to two angles in another triangle, then the triangles are similar. You don't have to look at the sides. You don't even have to make sure all three. Just that you have two pairs of congruent angles. Side angle side similarity. You need to have two pairs of sides that are in proportion, and then the angle between them has to be congruent. Kind of like your side angle side when we proved them congruent, but instead of the sides being equal, they have to be in proportion. And then your last way is side 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 similarity. As long as all three pairs of sides are in the same proportion, then the triangles are similar. You don't have to worry about looking at the angles. Good? The next third of the page is the theorems with pictures. So your first one, angle, angle. T and R are congruent to P and L. So since I have two pairs of congruent angles, those triangles are similar. Same shape, different size. Side angle side similarity. Angle A is congruent to angle D. Below the picture, I typed out that the ratio of AB to DE should be equal to the ratio of AC to DF. So if AB is 2 and DE is 3, and I make AC 10, what would DF have to be so that they're proportional? 15, good. Because then this is the ratio 2 to 3 as well. That's your side angle side. Your angle has to be sandwiched between the two sides. And then your last one, if all three pairs of sides were corresponding, or mirror in proportion, then your triangles are similar, and you've been doing that one a lot. At the bottom, given that MX is what to AB? Perpendicular, you have to decide if the triangles are similar. Well, what does it mean when lines are perpendicular? Yeah, they make the 90-degree angles, so those are marked down there at angle X. And then angle A they give you is 58, and angle B is 58. Would that be enough to say that the two triangles are similar? Yes, okay. It says explain why. You got to give me one of those 3 ways. Okay, angle, angle, similarity. And that's what you would write down. Angle, angle, similarity. Then it also says give your similarity statement. So triangle MAX is similar to what? KBX, right? Max would be similar to KBX. You either have to have two pairs of congruent angles, all three sides have to be proportional, or two sides in an angle. Number 2 on the top of the other side. Explain why these must be similar and write a similarity statement. I always look for angles first. I look to see if I have congruent angles before I ever check sides. Do we know if we have any pairs of angles congruent here? Who said yes? Which ones? Vertical. Good. You have a pair of vertical angles at V. So we know that these angles are congruent. Do we know if any of the other pairs are congruent? No, because I don't have parallel lines to give me the alternate interior here. Now we have to compare the sides. It's not always top to top, bottom to bottom. What do we always have to check? Like what would you put 18 with? Why not 24? They're both on the top.
It's just not how it always works.
Okay, so why would you put it with 36? Good. We go long to long, short to short, or bigger to bigger, and smaller to smaller. 18 is the larger of the two in this triangle, so I'm going to put it with 36, the larger of the two over there. 18 over 36 reduces to what? 1/2. Check your other one. 12 over 24, what do we get there? So are our triangles similar? Okay, what's your explanation? Good, side angle, side similarity. And then your triangle congruency statement, if I say ZVY, what do you say? Good, XVW. Cool. So when triangles are similar, then we know corresponding angles are congruent and corresponding sides are proportional. For number 3 here, it says ABCD is a parallelogram, find WY. So we have to find the length of WY. Did you find that little segment on your picture? Did you see it? What is, like, segment WY is a segment of what kind of polygon? Triangle, good. So we're trying to find the length of this triangle, or this length of the side on the triangle. I'm just going to call it P. I'm trying to find this P here. What do you think?
You have to set up a proportion.
Okay, sides are proportional when the triangles are what? Congruent or similar?
Similar.
Do you know if the triangles are similar?
No.
Okay, let's determine if they're similar first. We have 3 ways. Side, 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 side angle, side, or angle, angle. Do you know anything about the angles? We have a pair of vertical angles. See the little tiny upside down triangle and then the little one that's a little bigger? So I know that these angles at W are congruent. Zach? Okay, this is a parallelogram and it's marked on us that these lines are parallel. And then I could use like A's Y as a transversal. So then angle Y and angle A have to be congruent because they're alternate interior. What does that tell us about the 2 triangles then? They're similar by what? Okay, so Gracie, now that we know the triangles are similar, can we set up a proportion? Good. I'm going to start with the unknown. P, well, in the bottom triangle, corresponds with what? 5, good. As 10 is to, awesome. P is to 5 as 10 is to 4. 4P equals 50. Divide by 4. 12.5?
Yeah.
12.5. So you got to make sure the triangles are similar before you can set up your proportions. All right, go ahead and do number 4 right below that. If I look for the smallest side of that first triangle, 8 goes with 6, divide by 2, and you should get 4/3. Longer side, 12 to 9, divide by 3, and you get 4/3. You don't really have to check 8 to 6 again. So are these triangles similar? Yeah. By side, 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 right? Triangle EFG is similar to triangle ABC. On your similarity statement, you really only have to check right now that G and C are in the same spot. Why? Got it, Zach? Yeah, bless you. Good, because GE and GF are going to be in the same proportion as AC and BC because they're all the congruent. They're isosceles triangles. You could also think of it as saying, well, when triangles are similar, all their corresponding angles are congruent. So all 4 of these angles are the same. So it wouldn't matter if you put E with A or if you put E with B, just as long as C and G are together. Cool. Here. Oh, number 5. In sunlight, a cactus casts a 9-foot shadow. At the same time, a person 10 feet tall casts a 4-foot shadow. 6 feet. What did I say? My bad. I don't even know where that came from. There's my cactus. Just shadow. Yeah. You see his badge? This is cowboy hat on top. It's not a very good shadow. He doesn't have a gun. It's just a cactus. It's not like it's a dragon or anything.
Target practice. You can target practice with the.
He could, but he doesn't need a gun. He kills people with his kindness. Someone said that in first period. Okay, so the whole where it says like use similar triangles part of it comes in because you know how they have rays and then these rays like cast down like this or whatever. Yeah, and that's how you get your shadow because the cactus is blocking the sun ray. Well, this cactus grew perfect out of the ground for me, so it's perpendicular to the ground. And the sheriff is standing straight up from the ground, so they have 2 right angles. Okay. And the angle at which the sun ray is hitting the ground, those are supposed to be congruent. So they're saying these triangles formed are similar by angle. You technically don't need similar triangles, though, because you can just set up a proportion. Because we're taking these measurements at the same time of the day. We had a couple of them like this way back on one of our first worksheets. What's one proportion I can use to find my height of my cactus? 9/6. And 4/x? Oh. Yeah. 9 and 4 are their shadows. Okay. So here you have cactus shadow, right? And then you have sheriff shadow. What's 6 represent? The sheriff's height, right? What's the X represent? Okay. So you've got shadow to height, but you got cactus over sheriff and then sheriff over cactus. What do you want to flip? Good. You want to do like 9 is to X as 4 is to 6.
Yeah.
Do you see that?
Yeah.
Okay. That's one proportion. You could have done like X over 6 equals 9/4. I mean, there's a ton of them you could do. You could do 6/4 equals X over 9 as well. Multiple. Regardless, when you cross multiply, you should get 4x equals 54. Divide by 4. What do we get for the height of the cactus? 13.5 feet. If you need to, when you're doing your homework, draw a little picture. I mean, it doesn't have to be that detailed. You can just draw lines. You should have seen my one this morning. It was in color. Like I made a green cactus and my cowboy hat on blue jeans and boots and a yellow sheriff star. Do number 6 on your own. Look for angles first. Do you have any pairs of congruent angles on that first one? Okay. Then check your corresponding sides, short to short, long to long. So 6, my smaller side, would correspond with what? 9. 6/9 reduced by 3 gives you, and then 8/12 reduced by 4, and you get, so are these triangles similar? Yeah, by which of our 3 ways? Good. Side angle side. Triangle AXB is similar to triangle CXD. That's maybe yours was right, your similarity statement. Okay, how about B? Do you have any pairs of congruent angles? Okay, I've got vertical angles again. Compare my ratios. Why not? What do you mean?
Can't get angle, angle, side. That's the angle, side, angle, right?
But you can like find the missing one and then do them.
How can I find the missing one? Do you know if the triangles are, but do you know if they're similar yet? You can't find anything unless you know for sure they're similar. Does this match the pattern side, angle, side?
No.
Which angles do we need congruent for it to go side, angle, side? Okay, which angles? A and C, right? If A was congruent to C, then that would go side, angle, side. Right now it's going angle, side, side. We don't have an angle, side, side. These ones are not similar. I don't know. Not the side, angle, side similarity pattern. That angle is not between the two sides. All right, C. Look for angles first. Do you have any pairs of congruent angles? What are they? Vertical. Any other? Alternate interior. So like X would be congruent to M. Good. Can I do T and W as well? Yeah, do I need to? Because I already have my two pairs. So these triangles are similar by angle, angle. Triangle MRT similar to XRW. Do you know who Mr. T is? No. Pretty cool. He's a big black guy that wears all the gold chains and he's got like a mohawk. He wears like a jean denim vest. A-team? Okay. We're going to skip 8. We're going to do number 9. Joan places a mirror 24 feet from a base of a tree. When she stands 3 feet from the mirror, she can see the top of the tree reflected in it. If her eyes are 5 feet above the ground, how tall is the tree? So the height of the tree is to the height of Joan. As the distance the mirror is from the tree, the distance Joan is from the mirror. That's one proportion. 3x equals 5 times 24. Divide by 3. You should get x to be 40. You sure can. Questions on this? Okay, you're just continuing to set up proportions, and you're also proving triangles similar. Here's your homework.